I'm very pleased to be here to talk briefly about a subject which has been close to my heart for the last 30 years. Surface engineering is part of our everyday life and has a financial benefit to our GDP of around £140 billion per year. In modern manufacturing, it is impossible to design new products without modifying the surface in some way to achieve the desired performance. Surface engineering is one of the 22 national competencies and enablers across all high-value manufacturing centres. The Surface Engineering and Advanced Coatings Advisory Board has successfully captured the essence of the UK surface engineering community in the document we are now launching. I've been asked to talk about one example where the UK engineering community has made significant recent advances. One particular project I'm very proud to be part of is the HMS Queen Elizabeth aircraft carrier. The aircraft carrier is the largest warship in Royal Navy history. What's more, this is a British engineering project. The ship's propellers are twice the size of a double-decker bus and the flight deck covers some 4 acres. The ship is built from a colossal 80,000 tonnes of steel and has 3.4 million yards of cabling over 90,000 pipe spools. From the keel to the masthead, she stands as tall as Niagara Falls, and if she was berthed outside on the Thames, she would be longer than the Houses of Parliament by a good 20 metres. With 7 coats of battleship grey paint over an area the size of Hyde Park, she's more than 3 times larger than HMS Illustrious. The Queen Elizabeth aircraft carrier is designed to carry 36 F-35C Lightning fighter bombers, part of our Joint Strike Fighter fleet. The biggest challenge from a surface engineer's perspective was to deliver a carrier deck coating that could withstand the aerothermal gas wash generated by the aircraft engines. In the case of STOVL, short takeoff vertical landing aircraft, traditional paint systems are no longer capable of meeting the extreme environments experienced on the surface of the aircraft carrier deck when the F-35C is conducting hover transition and vertical landing on the surface. A metallic non-skid coating with a unique sealing system and its large-scale preparation and application involving thermal metal spray coating had to be developed to the technology readiness levels acceptable for application and long-term support of the HMS Queen Elizabeth and HMS Prince of Wales, the second such ship to be built for the fleet. The northeast of England, home to monitor coating since 1927, has long been one of the unsung heroes of technological innovation. Continually proving itself as a worthy player in a global arena, Newcastle upon Tyne has a proud history of shipbuilding and support services. Now part of a multi-billion euro organisation with more than 35 operations throughout the world, Monitor Coatings, stronger with Castellan Eutectic and the Met Group, continue to pave the way for surface engineering innovation through inward investment and research and development. I would just like to add my thanks to the Knowledge Transfer Network for their expertise and help in solving some of the many technical problems during the design of the coating system. I would also like to thank Eddie Trott, STOVL Reversion Lead from the Thales Group, for his outstanding contribution to the development of the flight deck coating. Also Brian Norton and his team at Indestructible Paints for the contributions to the sealing process, and finally to my wife Rebecca and her application team for the development and deployment of the coating system on the carrier deck.